All right, so for this one, have money in a lunch account. We're going to spend a certain amount every school day. So I have to write and graph a linear equation to represent that. And then how many school days will it take to spend all the money in the lunch account? So yeah, it's a good practical kind of question. How long will this money last, right? If we keep spending the same amount every day at school. So first thing to think about as far as your graph goes, well, we have to write the equation first. Let's do that. So to write the equation, you know, think about that you're starting with $110 and you're spending $275 every day. So you're losing that money or you're subtracting that money. So you're subtracting $2.75 every school day. And so every school day is going to be our X value. So, so this is our, however many school days we have, you know, been to school after we had that $110 put into the account, then that's the value for X. And the Y value is how much money we have. So it's a pretty common thing that you'll see is that a value of money, dollars, is going to be your Y value. And I do this because it's the vertical value, you know, in your graph. It's the up and down kind of time, days, seconds, things like that, hours. Those are almost always going to be the X values. Not saying it's impossible for it to be different, but almost always that's going to be the case. So that's a good rule of thumb to know. Okay, so think about, you know, what your graph should look like. This is money in your account. You want to know how long until it spent all of it, which would be 0, which is, you know, flat on the x-axis, right? Or no, at 0, 0, not 0, 0. At 0 on the y-axis. Sorry about that. Didn't mean to be confusing. So anyway, for those reasons, you're going to want, you know, this graph. I'm not saying you couldn't use a full graph at all because, you know, it is possible to go into debt, right? It is possible that you would owe the school money, right? And so that number, you could go into the negative values. So that could actually happen. I'm going to use this for simplicity and because we are not going to be looking at just, you know, an unlimited number of days. We're going to be looking at how long it takes to spend all the money, which would bring us back to $0, not a negative number. So anyway, okay. So we wrote a linear equation. It's linear. The X value has a degree of 1. It's an understood 1 exponent there. And that represents the balance. So this is the Y is the dollars in our school balance, school account, and the X is the school days, the number of days that we have used it. So think about it. After 0 days, like on the weekend, before you go back to school knowing that you have $110 in your account, you have $110 there, right? You haven't taken off any of those $2.75 charges. So once you go back one day, it takes off 1 times 275, which is $2.75. It takes that away. After 2 days, it takes off 2 of those, and so on. So to graph this, we have lots of different options. You know, after 0 days, remember, it would be the $110. So we want this to go to 110. So we really need to think about the scale that we're going to use here. And that's going to be important as we, you know, figure out how to make this graph look or represent the numbers really well. If this graph went 1 bar higher, I could just count by 10s. That would be nice. By 20s, it would be 20, 40, 60, 80, 100, 120. So I wouldn't use very much of it. I think I'll do 15s just to kind of use as much as I can. So 15 there. All right. Now, not have to count by a certain number, but this will keep all of our numbers on the graph. And I know that because this is dollars, you know, on the y-axis, and I know that it's not going to be more than $110. So at 0 days, we're at $110. And so we're going to have to be approximate, you know, about halfway. So a little bit more, well, a little bit less than that, excuse me. We're already at 105. So we'll call it that. That may be just a little bit low. All right. So I'm going to bring in the calculator just to let you kind of see this more plainly. Okay. I'll use the table. It's on the table right now. So let's see after 1 day. We talked about this, but after 1 day, we're substituting the x with a 1. Okay, we're down to $107.25. So $107. So we'll approximate it. Still is more than 105. Now that's if our graph is going to go by ones here. So if you're writing as you're watching, I wouldn't do that because I want to show you something I just want to point out. So just kind of watch for a moment. So after 2 days, we're down to $104.50. So after 2 days, it's a little bit less than $105. Okay. Let's do 3 days. 110 minus 2.75 times x, and now we're saying x is 3 days. We're down to $101. Okay, so at 3 days, still over $100, and this should be linear. So yeah, I feel like this should have been higher. Got to have been more accurate. I mean, we're having to very, very much be approximate with this, right? And some of that is realistic. That's real life. It's going to be that way. These numbers are values that are valid. These are accurate numbers, but you're having to be really very approximate with your graph, probably, because you're probably not going to have a graph that has every tick mark all the way up to $110, right? That's not very realistic. So if you notice that, you know, after 3 days, we still have over $100. We're not going to get to 0 this way by going by ones. And so, you know, I would probably change the x-axis here. I would probably change, I like it, that one there. What I'm counting by. Just like we're counting by 15s on the y-axis, our x-axis can be a different scale as long as the scale is consistent going across. So I want to show you this nice table. Here I can type in exactly our equation, $110 minus $275 a day. And let's say I want to start, well, let's start at 0, excuse me, change that to 0. And it's going to go up 1 day at a time. And we can just kind of see the numbers that we were getting on the other, when we were typing it in 1 at a time, you know, really tedious. So after 0 days, you know, you have that $110 because you haven't gone to school, you haven't spent the money. After 1 day, 2 days, and so on. And so this will show you the values. So notice that after 4 days, we're down to $99. It's a nice number. After 8 days, we're at $88. It's nice and round as well. 12 days. Okay, so there is a pattern to that, which is kind of neat. It's not all, doesn't always work out that way. But 4, 8, 12, you know, counting by 4s here. Let's see how far that would get us. 4, 16, 20, 24, 28, 32, 36, 40. Yeah, that would give us a good sense of where the numbers are. So That doesn't mean you have to set it up that way. I'm just noticing that on the table that those numbers are cleaner and those might be easier to graph. So I'm gonna go with that. After 4 days, we're down to $99. So we'll approximate where that is. After 8 days, we're at $88. So 8 days is below 90. Okay. After 12 days, 77. And, you know, most of the time, if you've graphed 4 or 5 points, then you have enough really probably information to have a good sense of where your line is going as far as what this is asking you to do for the graph. I'll do one more though, just to see it. So 16 days, we're down to $66. So 60, between 60 and 75. So somewhere like that. All right, let's go ahead and connect the dots as best we can. You know, you can see that my line was not really super accurate there, was it? Maybe something like that. You know, trying to approximate and get the line, it's called a line of best fit. If you've studied that yet or not. Okay. Lots going on here. So let me move. I'll just move the calculator off. Okay, so this is our equation. This is our graph. That's approximate based on the values that we have. And then how many school days will it take to spend all the money in your lunch account? Okay, so think about all the money. Y is the dollars. And so think about how much money will you have in your account if you've spent all your money, right? You'll have $0, right? So let's substitute Y with 0 because we don't know the number of days. We're trying to figure out the number of days. That's the question here. How many school days? That's X. So what we're going to do is just solve this equation for X. We're going to get X equals, or a number equals X, something like that. So when you look at this, you know, we've got a number and an X value. So let's subtract 110 from both sides. Get negative 110 equals negative $2.75 times X. So let's divide both sides by negative $2.75. All right, so let's bring in that handy dandy calculator. Let's go back to our regular screen. We're going to do negative 110 divided by negative 2.75. And it comes out nice and clean to 40, which is interesting. All right, so X equals 40. 40 what? How many school days? 40 days. So that's our answer to this question B. Now that tells me that my graph is off just a tad. It really should have been there. So let me change colors and just do a different one that would be a little more accurate. So if that's 110, and if we know that at 40 days we should be at 0, you can kind of see like where the graph should have been if it was more precise compared to where it was by just approximating our data there. So good, you know, I think lots of realistic examples here of, you know, how being approximate can get you close, but it didn't tell me exactly. You know, it looks like it would be about 38 days before we would spend all of our money. Turns out it would actually be 40 days. Okay, so I think that's all I wanted to say about that. I think I've said plenty about it. I hope that was helpful. See you next time.